So for this is our second to last lesson before our test. We are talking about composition of functions. Basically, we're putting a function inside a function, okay? So I handed you out the paper. You're gonna either, if you don't want to write on the paper, you can use just to see, or follow along. So doing that. So what is composition of functions? Well, basically, it's when you write function f is written as g composed of f, and it's defined as g composed of f of x, which equals g with f of x substituted for x, okay? So you're substituting in a whole function for the value of x, okay? The domain of the composition consists of x values in the domain for f, and is the domain of g. So whatever your domain is for your function inserted, it's going to become the domain of the entire function. Okay? Function domain is not commutative. That means that when it reads f composed of g of x, it does not mean the same thing as g composed of f of x. This now means that you're plugging g into f. We're literally substituting a whole function into another function for the value of x. So we have a couple options on how to evaluate composition. First option A is evaluate the inner function first. Use the value, use this value, the first output as an input for the second function. So we're going to look at a mapping of that, and then we're going to fill in a mapping, and then we're going to do it independently of the mapping. So here's a mapping of the process. So if you see right here, it says G composed of f at 2, f of 2, given the inner. So our inner value is f of x equals 3x minus 5, and the outer function is g of x equals x squared plus 2. You start with the innermost, and the innermost thing is f of 2. So what f of 2 tells me is that I'm going to set x equal to 2 in f of x. So f of x is 3x minus 5. Where there used to be an x, there's now going to be a 2. I plug it in, I evaluate, and I get 1. The answer I get from evaluating, I'm going to take it and plug it into g of x. And g of x is x squared plus 2. And I plug in 1, and I get 1 squared plus 2 is 3. And so my final output is my answer. Okay, so this is the mapping. Now we're going to always create a mapping, no. But this is just to visually see how I plug in the innermost into the first function, get an output, and then I plug it in to the second function and get my final output. So let's try it. So we have G, f of 5, f composed of 5. Given the inner function, f of x equals 3x minus 5, and the outer function, g of x equals x squared plus 2. So we're going to start on the innermost. And the innermost thing says that f of 5. So I'm going to take x, set it equal to 5, and plug it into f of x. So what used to be an x is now a 5. 3 times 5 is 15. 15 minus 5 is 10. I'm going to take the value, and it's now become my new x equal value. And I'm going to plug it into g of x. And g of x is x squared plus 2, where x is going to become 10. 10 squared is 100. And 100 plus 2 is 102. My final output and my answer is 102. Like an algebra puzzle. So we're going to try it without the mapping. So here, this is what a typical problem would look like. It tells you what your f of x is, what your g of x is. And again, you're going to start from the innermost. So I'm starting from g composed of 2. So the first thing I'm going to do is find g of 2. G is 2x plus 3. So this is going to become 2 times 2 plus 3, which is 4 plus 3, which equals 7. So I did the inside. Now I'm going to do the outside. And the outside is f. F is x squared plus 4x. I'm taking what I got from my first output and I'm plugging it into my second equation. So it's x squared plus 4x. So where there's an x, it's going to become 7 squared plus 4 times 7, which gives me 49 plus 28, which equals 75. That's not 75. So move that now, which equals 77. And that is my final output. How do you feel?
I feel like I can do it.
You feel like you can do it? Good. So you're going to do it on this one. So pay attention to what's the inside. Find that output. All right. So you start with the innermost. And this innermost is f of 2.5. F of 2 and 5 tenths equals. So I'm plugging it into f of x. So that's 2 and 5 tenths squared plus 4 times 2 and 5 tenths. 25 times 25 is 625. So therefore 2 and 5 tenths squared equals 625. 4 and $2.50. If I have $2.50 times 4, that means I have $10. So my first output is 1625. And this is not my answer, it's my first output. So I'm now going to take that value and plug it into G. So we get G of 1625 equals, and that's 2 times 1625 plus 3. That equals 3250 plus 3. That equals 35. That's my final output. How do we feel? Good? All right. Well, there is a second method of evaluating. And we're going to go over that second method. It's option B. First off, if it's not written in function notation, write in function notation, which is what we were just working with. So function notation means that it's written as f of g of x or g of f of x. And that's function notation. We want to substitute one function into the other and simplify. So you're actually going to put the function in and then evaluate. Okay. So for example, we have f of x equals x minus 5 and g of x equals x squared. What is g composed of f at negative 3? So first thing we want to do is rewrite this. So g composed of f negative 3 equals g composed of, this is function notation. This is composition notation. This is function notation. So we're in function notation. This lets me know that I am plugging f of x into g of x. So we're going to find g composed of f of x. So instead of just x squared, it's going to become x minus 5 squared, which equals x minus 5 times x minus 5. I'm going to FOIL. We all remember how to FOIL. First terms, last terms, inside terms, first terms, outside terms, inside terms, last terms. It's 0. So we get x squared minus 5x minus 5x plus 25. And that equals x squared minus 10x plus 25. Step 2. And then step 3 is now evaluate. So f opposed at -3 equals, that means wherever there's an x, I'm plugging in -3. So we end up with -3 squared minus 10 times -3 plus 25. A negative times a negative is a positive. So we have 9 plus 30 plus 25. And that gives us 64. Now this option is helpful when you are using the composition more than once. So if you're evaluating at multiple points. So like if I have to find G composed of F at 2, G composed of F at 3, G composed of F at 6, all of these values, I now already have an equation that I'm going from. And I just got to plug in and evaluate. Being able to do this is going to be also really helpful for our last section of this unit. Any questions about any of these steps? So step 1, we rewrote it in function notation. Step 2, we actually substitute the entire f of x into g of x. And then step 3, we evaluate that's the number they're asking. All right, so let's try it again. This time, though, it says f composed of g at -3. So what that means is that this time we're taking g of x and we're plugging it into f of x. The best way to remember in composition notation is to read it from right to left. -3 is going to go into g. G is going to go into f. So -3 into g, g into f. So I'm going to actually do f composed of the function. F of x is x minus 5, but instead of just an x, it's going to become x squared. So that's what I'm working with, x squared minus 5. So the answer, what is f composed of g at -3? It equals -3 squared minus 5. A negative times a negative is a positive. 9 minus 5 equals 4. Okay. On the 4 student practice problems, you can choose whichever option you prefer, option A, option B, and work these 4 problems. All right, so on the first one, did you all use option A or option B? Option A, okay. So you plug -5 into G first, right? So you should have gotten G of -5 equals -5 plus 2 squared, which equals -3 squared, which equals 9. And then you have taken what you got from that and plugged into F. So F of 9 equals, well, 3 times 9, which equals 27. How to do it?
I did it backwards.
Remember the hint, you read it from right to left.
I was on, put it in script.
Yep, right to left. So I'm taking -2 and plugging it into F. So we get F of -2 equals 3 times -2, which equals -6. I'm going to take the result of that and plug it into G. We get G of -6, which is -6 plus 2 squared equals -4 squared equals 16. All right, if you chose to do option B, I'm going to do it on the last two just to show you. Option B means I'm going to plug in the function first and then the value. So I'm going to find F composed of G of X, which is 3 times X plus 2 squared. And then I plug in the value. So now I'm going to plug in the value. And it gives me 3 times 2 squared, which is 3 times 4, which equals 12. Again, you can evaluate the function first and then the numbers. So if I plug in F into G, that's G of F of X, which equals G is X plus 2 squared. So instead of just an X, it becomes 3X plus 2 squared. And now I evaluate, which gives me 3 times 4 plus 2 squared, which equals 14 squared, which equals 196. Whichever way you choose to go by doing it, it's up to you. Yeah. All right, so you do have homework tonight. It is assigned to you via Canvas. It is a Canvas classwork assignment. You're using your notes from today, tomorrow, today, Friday, and yeah. Are there any questions, comments, or concerns?